knowledge. Tonight, we listen closely, not to a single song, but to the invisible connection between sound and emotion. Music is one of humanity's oldest companions. It has followed us from the flickering light of ancient fires to the quiet hum of headphones in the modern night. It crosses language, time, and distance, communicating what words cannot. In every corner of the world, in every age of human history, music has been present, a constant thread woven through the fabric of existence. But what is music, really? At its simplest, it is vibration, organized waves of air that move through space. These waves reach the ear, travel deep inside the skull, and are transformed into electrical signals. From there, the brain creates meaning, color, and feeling, turning simple physics into profound experience. If we could slow time and watch a single sound begin, we would see air molecules compress and expand in patterns. Some waves are slow and long, heard as deep bass that resonates in the chest. Others are fast and short, perceived as high, bright tones that seem to dance in the upper air. Between these extremes lies an infinite spectrum of possibility, each frequency carrying its own character and weight. Pitch is simply the brain's way of labeling frequency, how quickly a wave vibrates. Loudness is its label for amplitude, how strong that vibration is. From these simple ingredients, an entire universe of sound can be built. A whisper and a shout, a flute and a drum, all emerge from the same fundamental principle: moving air, organized in time. The journey begins in the outer ear. Sound waves enter through the curved shell of the pinna, which focuses them toward the eardrum, that delicate membrane stretched tight across the entrance to the inner world. When the eardrum vibrates, it sets three tiny bones, the malleus, incus, and stapes, into motion. These bones, the smallest in the human body, form a chain no larger than a grain of rice, yet they are precise instruments of amplification. They amplify the vibrations and pass them to the fluid-filled cochlea of the inner ear. The cochlea, shaped like a snail's shell, is a masterpiece of biological engineering, a spiral chamber where sound becomes sensation. Inside the cochlea, thousands of microscopic hair cells sway with the motion of the fluid. Each cell is tuned to a specific frequency, like a key on a piano, waiting to respond to its particular note. High sounds activate hair cells near the base, low sounds near the tip. This arrangement creates a living keyboard, a spatial map of frequency that allows the brain to distinguish a whisper from a whistle. When these cells bend, they trigger nerve impulses that travel along the auditory nerve to the brain. In that moment, mechanical motion becomes perception, vibration becomes meaning, and physics becomes consciousness. The brain does not simply hear, it interprets. It compares patterns, detects rhythm, and recognizes melody against a backdrop of countless previous sounds. The auditory cortex, located in the temporal lobes on each side of the head, is the first major station for these signals. Here, in this strip of tissue no thicker than a few millimeters, the raw data of sound is transformed into the experience of listening. Cells here respond to particular frequencies and combinations, forming an internal map of sound. This map is not fixed, it is flexible, shaped by experience, attention, and learning throughout a lifetime. A violinist's brain may dedicate more space to the frequencies of their instrument. A person who speaks multiple languages may process tone differently than someone who speaks only one. Yet hearing music is never just about the auditory cortex. Almost immediately, neural activity spreads into regions that handle movement, emotion, and memory, creating a cascade of connections. This is why music can make us tap our feet, recall moments long forgotten, or feel sudden joy or sorrow. Sound triggers the body as well as the mind, activating ancient pathways that link perception to action. The amygdala, a small almond-shaped structure deep in the brain, reacts to emotional tones and music just as it does to voices or facial expressions. It is always listening, always evaluating. Is this sound safe or dangerous, comforting or threatening? A sudden minor chord can activate it, producing feelings of tension or sadness that seem to arrive from nowhere. A bright major harmony can release it into calm, like sunlight breaking through clouds. The difference between major and minor is small in physical terms, just a shift of a few vibrations per second. Yet, to the listening brain, it can mean the difference between celebration and mourning. Nearby, the hippocampus helps attach music to memory. It notes where we were, who we were with, and what we felt when we heard a particular song, creating rich associations that can last decades. Years later, a few opening notes can reopen that entire moment. The smell of rain, the texture of a sweater, the face of someone long absent, all can flood back through the doorway of a melody. Meanwhile, the nucleus accumbens, part of the brain's reward circuit, releases dopamine when we listen to music we enjoy. This same chemical is involved in motivation, pleasure, and learning. The brain's way of saying, yes, more of this. It explains why the rise of a melody or the drop of a beat can feel physically satisfying, like scratching an itch we didn't know we had. The anticipation builds, the resolution arrives, and the brain rewards itself for predicting correctly. But dopamine is only part of the story. Oxytocin, sometimes called the bonding hormone, increases when people sing together or play in harmony, strengthening feelings of trust and connection. Cortisol, the stress hormone, decreases when music is slow and familiar, allowing the nervous system to shift from vigilance to rest. Even heart rate and breathing can synchronize with tempo, entraining the body to the rhythm of sound. In this way, music regulates the chemistry of our inner world. It balances tension and release, mirroring the way we manage emotion throughout the day. Long before science could measure it, early humans understood this instinctively. Drums, flutes, and voices carried stories through sound, marking births, harvests, hunts, and grief. Music organized time before calendars existed. It united people before words fully could, creating shared experiences that transcended individual perception. Archaeologists have discovered bone flutes carved more than 40,000 years ago, hollow instruments shaped from the wing bones of birds. Even then, our ancestors were shaping air into art, finding meaning in organized vibration. They did not need to understand acoustics to feel what rhythm could do. They did not need to know about dopamine or the auditory cortex to recognize that music changed something fundamental inside them. Sound is physical, but music is psychological. It is the brain's ability to find order and meaning within vibration, to transform waves into narrative. Where noise is random, music is structured expectation. It is pattern that invites the mind to predict, to follow, and occasionally to be surprised. When scientists observe the brain during musical listening, they see remarkable coordination. No single area works alone. Nearly every network participates in the act of hearing. The auditory cortex processes pitch. The motor cortex keeps rhythm, even when the body remains still. The limbic system interprets emotion. The prefrontal cortex, involved in planning and judgment, tracks patterns and predicts what comes next, constantly refining its model of the music. The cerebellum, usually associated with balance and coordination, helps refine timing and smoothness of rhythm, ensuring that our internal sense of beat remains steady. Together, they turn sound into narrative, vibration into story. Neural activity does not stay in one place. It flows like a melody through the brain. Signals loop between hearing and feeling, between memory and imagination, creating circuits of meaning. The result is not just perception of sound, but an experience of meaning that feels whole and immediate. We do not hear notes and then interpret them. We hear meaning directly. The brain is constantly predicting. Even before a note is played, it anticipates what could happen based on everything it has heard before, drawing on a lifetime of listening. When a piece of music follows these expectations, we feel comfort, a sense of rightness. When it gently surprises us, we feel delight, the pleasure of a prediction revised. This is why repetition matters. A chorus repeated several times teaches the brain what to expect, creating a framework of familiarity. Each return feels familiar, yet slightly new, because context has shifted. The second time we hear a phrase, we know it better. The third time, we may notice details we missed before. Music can therefore hold us in a delicate balance between certainty and curiosity. We know enough to feel safe, but not enough to become bored, suspended in an optimal state of engagement. The brain rewards this state with pleasure and focus, releasing just enough dopamine to keep attention anchored. This is the sweet spot where learning happens, where memory is formed, where experience becomes lasting. At the same time, music is shaped by culture and learning. What sounds joyful in one tradition may sound unresolved in another. Scales, modes, and intervals vary across the world. Yet the human brain adapts to each with ease, learning the musical language of its environment as naturally as it learns spoken language. A child raised with pentatonic scales will find them as intuitive as another finds major and minor. From childhood, we internalize the musical language around us. Lullabies, television themes, songs sung at gatherings, all carve subtle pathways in the brain, shaping our sense of what sounds right. These pathways become the framework through which we later hear everything else. They are invisible but powerful, determining which melodies feel like home and which feel like foreign lands. Still, beneath cultural differences, certain responses are nearly universal. Fast, loud sounds tend to excite, activating the sympathetic nervous system. Slow, soft sounds tend to calm, allowing the parasympathetic system to take over. Smooth, predictable patterns help us relax, while sharp changes demand attention, alerting the brain to potential significance. The link between sound and emotion may have deep evolutionary roots. Early humans relied on hearing for survival, using their ears as much as their eyes to navigate the world. The crack of a branch, the growl of an animal, the tone of another person's voice, all carried urgent information. The brain learned to attach meaning to even subtle changes in sound, developing exquisite sensitivity to acoustic detail. Over time, this sensitivity became a doorway to art. Music seems to build on the brain's natural tendency to find patterns in sound and emotion in pattern. It exaggerates tone, rhythm, and pattern, turning perception into something larger than mere survival. What began as vigilance became, over millennia, a source of meaning and beauty. Entrainment, the tendency of the brain and body to synchronize with external rhythms, is one of music's most powerful effects. Even when we sit still, neurons align with a steady beat, firing in time with the pulse of sound. Heart rate, breath, and movement all adjust in small but measurable ways. The body, it seems, cannot help but join the rhythm, becoming part of the pattern. This alignment is why groups can clap, march, or dance together without effort. The music provides a shared timeline, an external clock that everyone can follow. Within that timeline, individuals become part of a larger pattern. Separate nervous systems, each with its own internal tempo, merge into a collective rhythm. In many cultures, music is not something separate from life. It is woven into ceremony, healing, work, and rest, inseparable from the fabric of existence. The drumbeat of Africa, the raga of India, the chant of the Pacific, each reflects how sound connects individuals to something larger than themselves. Music becomes a way of saying, "We are here together, we share this moment." Modern neuroscience supports what tradition always knew. Music is a social force, a way of binding minds and bodies into shared experience. It stimulates the same neural networks that handle empathy and language, activating regions that help us understand what others feel. Through sound, we practice connection. When we sing or play together, our brains literally begin to synchronize. Functional imaging studies show that shared musical experiences activate mirror neurons, cells that respond when we act and when we see others act. These neurons help us sense what others feel, forming the neural basis of empathy. They are why we wince when we see someone hurt, and why we smile when we see someone laugh. This mirroring underlies compassion and cooperation. It explains why a concert crowd can move as one, or why a choir can feel like a single breathing organism. Through sound, many nervous systems behave like one. The boundary between self and other becomes permeable, and for a moment, we are not alone. As we listen, we are also constantly evaluating. Is this sound safe or threatening? Is this pattern calming or energizing? The brain answers these questions silently, adjusting chemistry and attention as it does, preparing the body for whatever may come. Over time, we build personal soundscapes. Certain instruments feel like home, their timbres as familiar as the voices of loved ones. Certain voices feel like comfort, their texture wrapping around us like warm cloth. Certain songs become anchors in the changing weather of life, constants we return to when everything else shifts. In this way, music becomes part of identity. The playlists we return to reflect how we see ourselves and who we wish to be, a sonic self-portrait. Sound turns into a mirror for the inner world, showing us aspects of ourselves we might not otherwise see. In the music we love, we recognize ourselves. The journey of this story has only begun. In the next part, we will move deeper into this connection, exploring how music shapes memory, personality, and the sense of self. We will discover why some songs seem to understand us better than words ever could, and how the brain uses sound to navigate the landscape of feeling. For now, let the rhythm of breath become your guide, and let the night settle into its own gentle tempo. Every piece of music begins with a pulse. It may be slow and steady, like a lullaby, or fast and driving, like a dance. But beneath melody and harmony, rhythm is the foundation. It is the heartbeat of sound, the invisible thread that holds all other elements together. Without rhythm, music would be formless, notes floating without connection. With rhythm, each sound finds its place in time, creating structure that the brain can follow. The human brain is built to recognize rhythm. Even before birth, an infant's nervous system can detect the mother's heartbeat and the rhythm of her voice. These early experiences shape how the brain responds to time and motion, creating templates that last throughout life. The first rhythm we ever know is biological, a steady pulse that signals safety and connection. When we listen to music, we are not merely hearing patterns, we are predicting them. The brain's motor system, the same network used for movement, becomes active even when we sit still. It anticipates each beat, creating a sense of timing that binds perception and action together. Listening to rhythm is not passive. It is an active coordination, an internal dance. This predictive ability explains why we tap our feet or nod our heads in time. The auditory and motor cortices communicate constantly, aligning sound with physical readiness. Music prepares the body to move, even when we choose not to. The impulse to follow the beat is wired into our neural architecture, a remnant of ancient coordination. Neuroscientists call this process temporal entrainment, the synchronization of brain activity with rhythmic stimuli. When a beat is regular, neurons fire in rhythm, forming internal clocks that mirror the music's tempo. These oscillations influence attention, memory, and mood. They create a temporal framework that organizes experience, making time itself feel structured and meaningful. In a way, rhythm is the bridge between sound and life. Our bodies are already rhythmic systems. Hearts beat, lungs expand and contract, cells cycle through rest and activity. When external rhythms match these internal ones, harmony emerges. The boundary between inner and outer dissolves, and we become part of the music's pulse. Pitch 1%. Consider how a calm, slow tempo can slow the heartbeat, or how an upbeat rhythm can quicken it. These responses are not imagined. They are measurable changes in physiology, documented in countless studies. Music becomes a form of dialogue between body and environment. It speaks directly to the autonomic nervous system, adjusting our internal state without conscious effort. This connection between rhythm and biology is ancient. Long before written language, humans used rhythm to coordinate action. Drumming kept groups in sync while rowing, marching, or working. It allowed cooperation through shared timing, turning many individuals into a single coordinated force. In ceremonies and rituals, rhythm guided emotion and focus. A steady beat could lead to trance. A shifting tempo could evoke tension and release. The pulse of music served as both compass and mirror for the human spirit. It marked the passage of sacred time, creating space where ordinary awareness could transform. Modern research shows that rhythm continues to influence the brain in profound ways. Functional imaging reveals that when people listen to rhythmic music, activity increases in the cerebellum, basal ganglia, and supplementary motor area. These regions coordinate movement and timing, creating an internal representation of the beat. Even if a listener cannot physically move, the brain still simulates motion internally, rehearsing the dance it cannot perform. This simulation improves coordination and focus. It can also support rehabilitation after injury, offering pathways for recovery when others are damaged. In music therapy, rhythmic auditory stimulation helps stroke patients regain motor control by retraining timing pathways in the brain. The beat provides an external structure that the nervous system can follow, step by step, back toward wholeness. In this sense, rhythm is not only expressive, it is restorative. It gives form to recovery, guiding the brain back toward order when chaos has disrupted its patterns. The steady pulse becomes a lifeline, a reference point in the work of healing. Through repetition and consistency, the brain relearns what injury took away. The brain's perception of rhythm is flexible but deeply rooted. It relies on both external cues and internal expectations, constantly comparing what it hears with what it anticipates. We sense a beat even when it is implied, a phenomenon known as the missing beat illusion. If a drummer suddenly stops playing but the music continues, we still feel where the beat should be. Our minds fill in what is absent, maintaining continuity. That tendency to seek pattern reflects a broader truth. The brain is a rhythm-making organ. From neural oscillations to thought patterns, timing shapes perception. Everything the brain does unfolds in cycles, waves of activity that rise and fall like breath. Alpha and theta brainwaves, for example, correspond to relaxed and meditative states. Slow musical rhythms can enhance these patterns, guiding the listener toward calm. This is why certain tempos are used in mindfulness practices and sleep stories. They align neural timing with peace. The brain begins to resonate with the external rhythm, slowing its internal tempo to match. In contrast, faster rhythms activate beta waves, associated with alertness and action. The tempo of sound becomes a dial for consciousness, shifting the balance between relaxation and focus. A drummer can change the mood of an entire room simply by adjusting tempo. Slow the beat, and tension drains away. Accelerate it, and energy rises. Our ability to perceive rhythm also connects to language. Speech has its own musicality, a rhythm of syllables, pauses, and emphasis. Children learn language partly by recognizing these patterns, internalizing the tempo of conversation before they understand meaning. Music strengthens the same neural circuits, improving timing and auditory processing. This overlap between rhythm and speech reveals how music shaped evolution. Before humans developed complex language, rhythm and tone likely served as tools for communication. The rise and fall of pitch, the repetition of pulse, these carried emotion and intent long before words. A steady beat signaled calm. An erratic one warned of danger. Some anthropologists believe that rhythm may have been the first shared art. By keeping time together, early humans created trust and cooperation. The act of drumming or chanting as one forged social bonds essential for survival. When the group moved in rhythm, individual differences faded and unity emerged. Today, we feel echoes of that ancient synchronization in concerts, choirs, and dances. Thousands of people can move together to one rhythm, their nervous systems aligning. The sense of unity that follows is not metaphorical. It is biological. Brain activity begins to mirror across individuals, creating a collective pattern of neural firing. In studies measuring heart rate and brain activity, participants exposed to synchronized rhythms show increased oxytocin and feelings of closeness. Rhythm literally brings people into harmony, dissolving the boundaries between separate selves. This is why music has always been central to ritual and celebration. It transforms a collection of individuals into something larger, a unified presence. At the individual level, rhythm shapes our experience of time itself. A regular pulse provides predictability, while irregular patterns create surprise. Music plays with this tension, alternating between order and variation to hold attention. The mind craves both, the comfort of pattern and the excitement of change. When rhythm stabilizes, we feel safe. When it shifts, we feel alert, our attention sharpening as the brain updates its predictions. The interplay between these states mirrors the balance of life: calm and change, rest and motion. Music teaches us to navigate this balance, to find ease even as patterns shift. This is why lullabies, with their slow repeating phrases, calm infants. The repetition signals security, telling the nervous system that all is well. In contrast, a sudden pause or syncopation catches attention, stirring curiosity or anticipation. The brain perks up, wondering what comes next, engaged by the gentle violation of expectation. The brain rewards this balance through the release of neurotransmitters. Predictable rhythms produce serotonin and calm. Unexpected variations spark dopamine and excitement. Music keeps us between these poles, comforted yet engaged. It is a dance of chemistry as much as sound, a conversation between brain and beat. Even silence plays a rhythmic role. In music, pauses are not empty. They are part of the timing, spaces that give the notes around them meaning. The absence of sound heightens awareness, preparing the mind for what comes next. We lean into the silence, listening for the return of rhythm. The auditory cortex treats silence as information. It measures duration, marking time between events, creating a map of what is present and what is absent. In this way, stillness gives rhythm its meaning. Without the pause, the beat has no contrast. Without rest, motion has no weight. Through rhythm, the brain constructs expectation, the foundation of emotion in music. Every pause, every beat creates a future moment to anticipate. Our nervous system lives slightly ahead of sound, predicting the next note before it arrives. This forward-leaning awareness connects directly to pleasure and engagement. When the next beat falls exactly where we expect, we feel satisfaction. When it arrives just late enough to surprise, we feel delight. Music becomes a dialogue between certainty and discovery, a gentle game the brain plays with time. This interplay also shapes movement. Rhythm triggers the basal ganglia, the brain's timing center, and the premotor cortex, which prepares muscles to act. Dancers often describe losing themselves to rhythm because their conscious control fades. Movement becomes instinctive. The thinking mind steps back, and the body follows the pulse without hesitation. The body becomes music's echo. Even small rhythmic cues, a hand tapping, a head nodding, reflect synchronization between outer sound and inner timing. In therapy, this synchronization is used to improve coordination and attention. Drumming programs for children with ADHD, for example, enhance focus and impulse control by training timing pathways. Rhythm organizes not only sound but behavior, giving structure to systems that might otherwise feel scattered. The external beat becomes an anchor, a steady reference point. The power of rhythm also extends to emotion. Heartbeat-like tempos can evoke comfort, reminding us of safety and intimacy. Faster pulses can induce excitement or joy, activating the nervous system in ways that feel enlivening. The tempo becomes an emotional code the brain deciphers without words. Across cultures, similar tempos appear in rituals of both celebration and mourning. The universality of pulse suggests that rhythm speaks directly to the nervous system, bypassing learned language. It is emotion made physical, feeling translated into time. A drumbeat can express what words cannot, carrying grief or joy in its simple repetition. Some rhythms even seem to transcend culture entirely. The tempo of a resting heartbeat, around 60 to 70 beats per minute, appears in lullabies worldwide. This is not coincidence. It is biology. The brain recognizes this tempo as the rhythm of safety, the pulse of a mother holding a child. In the quiet of night, even the absence of external rhythm leaves us aware of our internal one. The slow beating of the heart, the pattern of breath, these are the original metronomes. All music begins here, in the body's innate sense of time. Every drum echoes the heart. Every pause mirrors the space between breaths. As this chapter closes, imagine the gentle alignment of pulse and sound, the rhythm of your breathing matching the rhythm of thought, the brain settling into harmony with its own design. Notice how the body already knows how to follow time, how each inhale and exhale creates its own music. There is nothing to control, only patterns to notice and join. In the next chapter, we will explore melody, how sequence and contour turn rhythm into song. We will discover how the brain transforms tone into feeling, meaning, and beauty. But for now, let the invisible metronome within you continue to mark time, steady, ancient, and alive. Let each beat be a reminder that rhythm is not something we create. It is something we are. Every song we know begins as a single note, a vibration, a frequency, a small wave of air. Yet when one note meets another, when tones rise and fall together, they form melody, the voice of emotion in sound. It is the golden thread that connects sound to soul, weaving through time and memory. Melody is what lingers after the rhythm fades. It is the part we hum without thinking, the thread that ties music to memory, following us through years and across distances. The brain is exquisitely tuned to melody because it speaks the same language as speech, variation in pitch, contour, and cadence. Long before we understand words, we understand the music within them. When we hear a melody, the auditory cortex analyzes the pattern of frequencies. But perception goes far beyond recognition. It becomes interpretation, prediction, and feeling. The brain traces the motion of each pitch, predicting where it might go next. When those predictions are met or gently defied, we feel emotion, a cascade of chemistry and electricity. This dance between expectation and fulfillment lies at the heart of musical pleasure. In each rise and fall, the brain experiences tension and release, uncertainty and resolution. Neuroscientists call this predictive coding, the brain's constant attempt to forecast the future. Every melody is a puzzle of possibilities, and each correct guess releases dopamine. It is not the sound itself, but the act of prediction that gives listening its joy. The brain celebrates its own accuracy, rewarding itself for understanding patterns. Consider a familiar tune. As it begins, you already know what comes next, and when it does, the brain rewards itself with quiet satisfaction. But if a composer changes a single note, delays a resolution, shifts a tone, surprise awakens curiosity. The emotional impact grows, deepening from mere recognition to genuine wonder. Music moves us because it mirrors life. Moments of uncertainty followed by relief, longing answered by calm. We recognize this pattern instinctively, written into our neural architecture. Each melodic phrase becomes a miniature story, with beginning, tension, and ending. The brain follows this narrative as naturally as it follows breath. Harmony deepens that recognition. While melody speaks through sequence, harmony speaks through coexistence, multiple notes sounding together. Their interaction creates texture and color, the emotional palette of music. Where melody draws a line, harmony fills the space around it with depth and dimension. In the brain, harmony activates networks linked to emotion and social understanding. We respond to consonants, intervals whose frequencies align smoothly, with pleasure and relaxation. Dissonance, where frequencies clash, creates tension that demands resolution. The brain perceives this clash as a question waiting for an answer. Yet both are essential. Too much consonance can feel predictable. Too much dissonance becomes chaos. The balance between them mirrors the balance between comfort and challenge in human experience. Life itself moves between harmony and discord, seeking equilibrium. Different cultures interpret these sounds in unique ways. Western traditions associate major chords with happiness and minor chords with sadness, but these links are partly learned. Across the world, other scales and intervals carry different emotional meanings, shaped by language and environment. What sounds joyful in one tradition may sound contemplative in another. Still, the underlying perception of tension and release appears universal. Brains everywhere respond similarly to resolution in sound, suggesting something deeper than culture. This suggests that the physics of vibration speaks to something ancient and shared, the biology of expectation. Our nervous systems, regardless of origin, all seek pattern and completion. To understand how melody touches memory, we turn to the hippocampus, the brain's archivist. When music repeats, patterns of neural activity strengthen, forming associations that can last a lifetime. Over time, these associations bind sound to emotion and experience. A melody becomes inseparable from the moment it first touched us. This is why a simple tune can recall a forgotten moment with perfect clarity. The brain stores the melody as part of a sensory landscape. The smell of rain, the face of a friend, the feeling of youth. When the tune returns, the landscape returns with it. 3 notes can open a door to decades past, more vivid than any photograph. Music therapists use this connection deliberately. For patients with Alzheimer's disease, familiar songs can reawaken speech and emotion even when other memories have faded. The melody becomes a key that unlocks dormant neural networks. Where language has dissolved, music remains, bridging the gap between past and present. In those moments, we see how deeply melody intertwines with identity. It is not only remembered by the mind, but felt by the body, stored in networks that transcend conscious thought. Brain imaging shows that familiar melodies activate both auditory and motor areas, even when no movement occurs. The body prepares to sing or play, echoing memory through motion. Harmony, too, shapes emotion through resonance. When two notes vibrate together, they produce additional frequencies called overtones. These overtones blend to form timbre, the unique color of each sound. It is what makes a voice recognizable, what gives each instrument its character. Timbre explains why a violin and a flute can play the same note yet sound entirely different. The brain recognizes these subtle harmonic fingerprints instantly, linking them to feeling. Certain timbres evoke warmth, others clarity or nostalgia. A soft, human voice releases oxytocin, enhancing trust and calm. A distorted guitar triggers adrenaline, signaling excitement. Every sound carries emotional information, and harmony magnifies it. Choral singing, for instance, produces rich harmonic overtones that envelop the listener. The overlapping voices stimulate reward circuits, often leading to chills or tears. Scientists call this phenomenon frisson, a shiver of pleasure that runs down the spine. It occurs when music activates both the auditory and emotional centers simultaneously. This creates an intense yet safe form of surprise, a moment where beauty overwhelms prediction. The brain releases dopamine not because it guessed correctly, but because it encountered something extraordinary. Melody and harmony, together, also influence the release of neurochemicals like serotonin and dopamine. The steady structure of harmony provides safety. The flowing unpredictability of melody brings excitement. Their combination reflects the emotional duality of life, stability within change. We need both roots and wings, both home and horizon. From a biological perspective, this interplay may have evolved to strengthen social bonds. Shared musical experiences create synchronized emotional states, aligning group behavior. When a tribe or community sings in harmony, the result is collective regulation, shared peace, or shared energy. Individual nervous systems begin to pulse as one. We still experience this today. A choir's swell, an orchestra's crescendo, a crowd singing together. These moments bypass intellect and reach something primal. Inside the brain, the anterior cingulate cortex lights up, a region involved in empathy and emotional awareness. It helps us feel what others feel, translating harmony into belonging. Harmony also teaches balance. Composers throughout history have used dissonance not to unsettle, but to remind us that beauty requires contrast. Without tension, resolution has no meaning. Without silence, melody cannot breathe, cannot find the space it needs to speak. The same principle applies to the human mind. Emotion gains depth through variation, sadness sharpening joy, longing enriching love. Music captures this truth effortlessly, expressing it without words. It shows us that wholeness includes discord, that perfection is not the absence of tension, but its resolution. Across time, musicians have explored how melody shapes consciousness. The chants of monks, the ragas of India, the scales of East Asia, all use melodic movement to alter attention and evoke spiritual states. Neuroscientific studies on chanting and mantra show decreased activity in the default mode network, the system responsible for self-focused thought. As melody repeats, The sense of individual boundary softens, replaced by calm awareness. In this sense, melody is a tool for meditation. It guides the mind away from narrative and toward presence, the same state sought through breath or silence. The repeating phrase becomes a focal point, something to return to when the mind wanders. Each return strengthens the pathway toward stillness. Every culture, regardless of language, uses melody to express emotion. Lament, joy, awe, and devotion all have their melodic signatures, certain intervals, rhythms, and contours. The brain associates each pattern with feeling, creating an internal lexicon of emotional sound. This lexicon is learned young and lasts a lifetime. Even infants respond to melody before understanding words. A mother's lullaby calms not through meaning, but through contour and tone. The rise and fall of her voice mirrors the rhythm of comfort itself. The baby's nervous system recognizes safety in the pattern long before thought or language emerge. The universality of melody suggests that emotional communication through sound predates language. Music may have been humanity's first shared language, not a code of words, but of feeling. A cry of grief, a call of joy, a tone of warning, all carried meaning through pitch and rhythm. We still understand these signals instinctively, written into our biology. As our brains evolved, we did not lose this capacity. We refined it. The structures that interpret pitch and tone overlap with those that understand speech. When we listen to melody, we are engaging the same networks that allow empathy and connection. Sound becomes a bridge between minds, carrying feeling across the gap. Harmony, meanwhile, provides emotional architecture. It is the scaffolding that supports memory and identity, the framework within which melody moves. When we return to a familiar chord, we feel at home. When the music drifts into a new key, we feel curiosity, even adventure, a gentle expansion of possibility. The composer plays with these reactions as a painter plays with light. By shaping pitch and interval, they sculpt emotion directly within the listener's mind. The result is not just art, it is communication across consciousness. Two minds, separated by time and space, meeting in the landscape of sound. In modern neuroscience, researchers use brain scans to study improvisation and creativity. When musicians play freely, the prefrontal cortex, responsible for self-censorship, quiets. The brain enters a flow state where melody emerges effortlessly, guided by intuition. Planning steps aside, and something deeper takes the wheel. This state reflects the purest form of musical expression, thought and sound moving as one. The musician does not invent the melody so much as uncover it, following patterns already present in the mind. Listeners share in this process. When music flows naturally, their brains mirror the performers, synchronizing patterns of emotion and anticipation. Connection deepens across the space between creator and listener. For a moment, two nervous systems harmonize, feeling the same tension, the same release. This is the power of melody and harmony together, not just to express emotion, but to share it, to create a space where feeling becomes mutual, where loneliness dissolves into resonance. In the next chapter, we will explore what happens when music stops, how silence shapes emotion. We will discover how the brain uses rest, pause, and space to make meaning out of sound. For now, imagine a single melody floating through the air. Familiar yet new, delicate yet strong. Within its movement lies every joy and every sorrow, every heartbeat and every thought. The brain listens, remembers, and feels. And in that moment, sound becomes life. Vibration becomes meaning. Let the melody settle into stillness, each note fading into the next breath. The music continues even in silence, playing on in memory and feeling. For as long as humans have created sound, they have used it to heal. Long before medicine became science, rhythm and tone were already tools of balance. Across the world, ancient cultures treated music as medicine. Drums aligned heartbeats in Africa. Chants guided meditation in Tibet. Stringed instruments soothed pain in Greece. Each tradition understood what modern neuroscience now confirms, that sound changes the body as deeply as it moves the soul. The vibration that reaches the ear continues into flesh, bone, and blood. The body itself is musical. Every organ pulses, every cell vibrates at its own frequency, creating an internal symphony of life. When the rhythms of the body fall out of sync, illness or stress often follows. Music restores harmony by reintroducing order through vibration, offering the body a pattern to follow back to balance. In scientific terms, this is entrainment, the process by which external rhythm synchronizes internal rhythms. When we listen to steady music, the brain adjusts its oscillations to match, creating coherence across neural networks. Heart rate, breathing, and even hormonal release can follow the tempo. The body becomes a mirror of the music, reflecting its patterns in biological processes. Slow tempos, around 60 beats per minute, often match a relaxed heartbeat. This is why lullabies and ambient music calm the nervous system so effectively. The parasympathetic branch, responsible for rest and recovery, becomes dominant, lowering blood pressure and easing tension. The body interprets the slow rhythm as a signal that it is safe to rest. At faster tempos, the opposite occurs. The sympathetic system activates, increasing energy and focus, preparing the body for action. For athletes and surgeons alike, rhythmic music can improve timing and precision. The right tempo helps the body perform at its peak, sharpening coordination and response time. In hospitals, music therapy is now used to reduce anxiety before surgery and pain afterward. Studies show that patients who listen to soothing music require less anesthesia and recover faster. The presence of rhythm gives the mind a place to rest, reducing the perception of discomfort. Attention shifts from pain to pattern, from suffering to sound. Music also stimulates the release of endorphins, natural painkillers produced by the brain. This effect is strongest when the music feels personally meaningful, when it touches memory or emotion. Familiar songs activate emotional circuits that modulate pain signals in the spinal cord. The music doesn't eliminate the sensation, but it changes how the brain interprets it. In this way, sound acts as both distraction and medicine. It pulls the mind away from suffering and changes the chemistry beneath it. The brain's pain centers, when engaged by music, show reduced activity. Meanwhile, reward centers light up, creating a cascade of relief and comfort. Certain frequencies can influence mood and attention through resonance. Low frequencies calm, vibrating through the chest and abdomen. High frequencies sharpen awareness, alerting the mind. This relationship between vibration and brain state is being studied through brainwave entrainment, using tones or beats to guide neural activity. The brain, like any oscillating system, can be gently nudged toward desired frequencies. When two tones of slightly different frequencies are played in each ear, the brain perceives a third tone, the difference between them. This is called a binaural beat, an auditory illusion created entirely within the mind. If the difference falls within the range of alpha or theta brainwaves, the listener often enters a relaxed or meditative state. The brain follows the implied rhythm, slowing its internal tempo. While research continues, many therapists find that gentle rhythmic sound helps patients focus, sleep, and release anxiety. The principle is simple. The brain prefers harmony. When presented with regular rhythm, it seeks alignment. Chaos fatigues the nervous system. Pattern allows it to rest. Beyond rhythm, melody and harmony also influence healing. Minor keys allow emotional release, giving sadness a voice. Major keys lift mood, suggesting resolution and hope. Simple, repetitive structures soothe the limbic system, providing predictability and comfort. The brain rewards itself for successfully predicting each note, releasing dopamine in gentle, steady waves. In neurological rehabilitation, melody can even rebuild language. Melodic intonation. Therapy uses singing to help stroke patients regain speech. The musical contour activates right hemisphere regions that mirror those used for language on the left. By singing words, patients bypass damaged circuits and create new ones, rewiring the brain through sound. Music's ability to rewire the brain, neuroplasticity, makes it a powerful tool for recovery. Rhythm helps Parkinson's patients regain motor coordination, providing an external cue when internal timing fails. Steady beats provide cues that stabilize movement, improving gait and balance. Where the disease disrupts the basal ganglia's timing, music supplies a replacement metronome. In Alzheimer's care, familiar songs awaken memories long thought lost. Even when names and places vanish, melody remains, stored in networks that span the brain. It stirs the hippocampus and limbic regions, reconnecting fragments of identity. A song from youth can suddenly restore a face, a feeling, a sense of self. This shows that music is not stored in one place, but distributed across networks: auditory, emotional, motor, and cognitive. When we listen, the brain lights up like a constellation, stars of activity across distant regions. The emotional power of music also influences hormones. Oxytocin, the bonding hormone, rises during group singing or chanting. This chemical supports empathy, trust, and social connection, essential ingredients in healing. When we sing together, we literally become more bonded at a chemical level. Cortisol, the stress hormone, decreases when people listen to calm or preferred music. The body enters a parasympathetic state, conserving energy and allowing repair. In this way, music acts as a regulator, tuning the body's chemistry toward equilibrium. It doesn't impose a new state. It guides the system back to its natural balance. The ancient Greeks described this balance as catharsis, emotional cleansing through art. Music allows expression that words cannot reach, releasing what has been held too long. When sound mirrors our inner state, it validates and releases it. We hear our grief, our joy, our tension reflected back, and in that recognition, something shifts. Modern therapists observe this in practice. In sessions with trauma survivors, improvisation and drumming can help externalize tension stored in the body. Vibration becomes a voice for emotions too deep to name. The rhythm speaks what language cannot, releasing trauma held in muscle and bone. In palliative care, music provides comfort beyond pain relief. Soft singing or instrumental tones create intimacy and dignity in the final stages of life. For families, these moments often become sacred, sound marking transition. The music acknowledges the threshold being crossed, holding space for what cannot be said. Music's effect on the immune system is also measurable. Studies have found increases in immunoglobulin A, an antibody linked to defense against infection, after listening to calming music. The relaxation response strengthens both mind and body. When stress decreases, the immune system functions more effectively, better able to protect and repair. Even outside of therapy, daily listening supports well-being. A familiar song during stress, a peaceful soundtrack before sleep. These moments train the nervous system. Over time, the body learns to associate sound with safety. The neural pathways strengthen, making relaxation easier to access, requiring less time to settle. Sound therapy extends these ideas into pure vibration. Tibetan singing bowls, tuning forks, and gongs create complex overtones that resonate through the body. Low-frequency vibrations are absorbed by tissues and bones, producing sensations of warmth and release. The sound is felt as much as heard, a physical embrace of vibration. Though some claims exceed evidence, many people report calm, improved focus, or emotional clarity from these experiences. Science suggests that part of this effect comes from the rhythmic breathing and stillness encouraged by the sound itself. Whether through voice, instrument, or resonance, the principle remains. Vibration restores balance. The body remembers its natural rhythms and, given the right cue, returns to them. Music's role in healing is not limited to individuals. Communities use it to recover from grief, conflict, and loss, gathering in song when words fail. After natural disasters, people often gather to sing, not only to mourn, but to rebuild connection. The shared rhythm reminds them of unity and hope, of the threads that still bind them together. At a biological level, group singing synchronizes heart rate and breathing. The resulting coherence mirrors emotional togetherness, bodies aligning as minds connect. Each voice supports the others, just as cells align within a living organism. The individual becomes part of something larger, and in that union, strength returns. In therapy rooms and hospital corridors, music continues to bridge science and humanity. It is both ancient and modern, a tool that reaches where words and machines cannot. The power of music in healing may lie in its paradox. It is both external and internal. We hear it from the outside, yet it moves within, touching places we cannot name. We choose it consciously, yet it touches what lies beyond awareness. It is deliberate and mysterious, planned and spontaneous, all at once. This duality mirrors the nature of the brain itself, a physical structure generating intangible experience. Sound becomes feeling, vibration becomes meaning, frequency becomes memory. Some hospitals now design soundscapes for intensive care units, replacing mechanical noise with soft, natural tones. These sonic environments reduce stress and promote recovery, creating spaces of healing rather than alarm. patients report improved sleep, fewer nightmares, and a stronger sense of safety. The auditory environment shapes not just mood, but the body's capacity to heal. In mental health care, personalized playlists help regulate mood. Music can shift depressive patterns by triggering dopamine and reawakening motivation, offering a gentle nudge toward engagement. For anxiety, slow instrumental tones act as anchors, grounding the listener in the present. The predictable rhythm becomes something to hold on to when thoughts spiral. Even in neonatal units, gentle lullabies have measurable effects. Premature infants exposed to soft singing gain weight faster and require less oxygen support. The mother's voice, rhythmic and familiar, stabilizes the baby's heartbeat. It is one of the first forms of medicine, connection through sound. Rate 100%, pitch 1%. Here, sound becomes touch, an invisible connection between nervous systems. The vibration crosses the gap between bodies, carrying comfort without words. The field of psychoneuroimmunology, the study of how mind, body, and immunity interact, now includes music as a factor in well-being. Through vibration and emotion, music links all three, creating coherence across systems. Ultimately, the healing power of sound reminds us that we are made of movement. Atoms vibrate, molecules resonate, thoughts pulse. Nothing in the body is truly still. When these rhythms fall into harmony, health follows naturally. Disease is often discord. Healing is the return to resonance. Music offers a pathway back, not by imposing order, but by inviting it. The body recognizes the pattern and remembers how to follow. In the next and final chapter, we will explore why music means so much to us, how it shapes identity, connects generations. We will discover how sound mirrors the emotional architecture of the human soul. For now, let the memory of sound settle like calm water. The music may fade, but the body still remembers its rhythm, carrying the pattern forward into rest. Every journey through music leads back to a simple question: why does it move us so deeply? We understand its mechanics, the vibrations, the brain activity, the chemistry. We know which areas of the mind light up when a melody begins, which hormones rise when a song reaches its peak. But the mystery remains. Why should patterns of air carry such emotion, such memory, such meaning? Why should organized vibration touch the soul as profoundly as human touch or spoken words? Perhaps the answer lies in what music represents: connection. Every note is the result of motion meeting resistance, of energy transformed into sound. When we listen, that vibration enters our bodies, becoming part of our own movement. The sound wave doesn't stop at the eardrum. It continues inward, touching bone, fluid, and nerve. In this way, music blurs the boundary between self and world. We do not simply hear it, we join it, becoming part of the pattern it creates. Inside the brain, music creates a remarkable network of unity. Auditory, motor, emotional, and memory centers synchronize their rhythms, creating a symphony of neural activity. Thought, feeling, and action align for a few fleeting moments. This integration is rare, a harmony within the mind itself, a state where all parts speak the same language. Perhaps that harmony feels like happiness because it mirrors balance, the brain's natural state of coherence. Music does not just reflect emotion, it restores it, guiding the system back toward equilibrium. From an evolutionary view, music likely evolved as social glue. Before complex speech, early humans sang and moved together, creating bonds through shared rhythm. Shared rhythm created trust, communication, and cooperation. A synchronized tribe was a stronger one, better able to hunt, defend, and survive. But beyond survival, music became expression. It allowed joy, grief, and love to find form. Emotions too large for words, too subtle for gesture. It turned experience into art, and art into memory. Through song, moments that would have faded instead became permanent, carried forward in melody. When we sing, even softly, we reveal what it means to feel alive. Vibration becomes emotion made, visible, the inner world translated into sound. Neuroscientists studying creativity describe music as a bridge between hemispheres of the brain, logic and intuition, structure and imagination. Composing or improvising engages both simultaneously, requiring calculation and inspiration in equal measure. The left hemisphere measures intervals, the right senses mood and color. Together, they create wholeness, each contributing what the other cannot provide alone. Listeners experience this same unity. Music quiets analytical thought and awakens empathy, allowing us to feel without needing to explain. It allows emotion to flow freely, unguarded by language. In the presence of music, the mind can soften its defenses and simply be. When a piece of music moves us to tears, the amygdala and nucleus accumbens, centers of emotion and reward, interact intensely. Dopamine surges as memory floods in, bringing with it the weight of everything we've felt before. We feel nostalgia, beauty, release. The body responds with goosebumps or breathlessness, as if awe itself were a physical force pressing against the chest. These reactions, though measurable, resist explanation. They remind us that emotion cannot be reduced to data, that some experiences transcend the language of science. Music touches something deeper, the awareness of being alive in time. It makes us conscious of our own presence, of the fleeting nature of each moment. Every note exists only in the moment it is heard. It rises, fades, and is gone, impossible to hold, always slipping away. Like a breath, it teaches impermanence. Nothing lasts, everything flows. The song continues only by letting each note go. This fleeting quality gives music its tenderness. It cannot be held, only remembered, and in that limitation lies its power. And yet, within that transience, it carries eternity, repetition, rhythm, renewal. The same patterns return across generations, linking us to those who sang before and those who will sing after. We listen because, for a moment, the boundaries between body and world dissolve. The pulse of the drum echoes the heart. The vibration of the string mirrors the voice. Pitch 1%. Music lets us recognize ourselves in the world around us. It shows us that we are not separate from the universe, but part of its rhythm. Across cultures and centuries, people have turned to music in every human condition. Celebration, mourning, worship, solitude. It has been a vessel for identity, protest, healing, and prayer, adapting to every need. Wherever we find people, we find song. From the first lullaby to the last hymn, music accompanies us through life. In temples and concert halls, in lullabies and laments, music connects the finite to the infinite. It turns emotion into something that can be shared, transforming isolation into belonging. The philosopher Friedrich Nietzsche once wrote, "Without music, life would be a mistake." Science might phrase it differently. Without rhythm and resonance, the brain would lack a means to integrate itself. Music is not an accessory to life. It is one of life's organizing principles. It structures time, organizes emotion, and creates coherence in a world of constant change. Inside every human brain, there exists a network that lights up in response to sound. But the degree to which it activates, the way it brings pleasure, movement, and empathy, is uniquely human. Other animals hear rhythm and tone, but none respond with art. None create symphonies, write songs, or weep at the beauty of a melody. This suggests that music is an expression of consciousness itself, awareness turned outward as vibration. It is how the mind listens to its own mystery, speaking to itself across time. In that sense, every song is a reflection of thought. Every melody is the shape of an idea that cannot be spoken, a feeling that exists before language. Even silence, as we've seen, plays a role. The pauses between notes mirror the pauses in thought, the space where understanding grows. Music teaches the brain to balance expression with restraint, sound with quiet. It shows us that meaning lives not just in what is said, but in what is left unsaid. Through this balance, music models wisdom. It shows that beauty depends on contrast, that emotion requires both movement and stillness. On a deeper level, music connects memory to imagination. When we hear an old song, the hippocampus reawakens past experience, while the prefrontal cortex projects meaning onto it. We are both remembering and reinventing, past and present intertwined. The song brings back what was, but we hear it through who we've become. The emotions we feel while listening are therefore not stored in the song itself, but created anew each time. The music becomes a mirror for the listener, reflecting what is present within. This may be why music feels timeless. It exists only in experience, yet renews itself endlessly. Each listening is unique, yet familiar, a conversation between memory and the moment. When groups share this experience, singing, performing, or simply listening together, their brains synchronize, heart rates align, neural oscillations converge, and a collective rhythm emerges. In those moments, individuality fades into harmony. The separate selves dissolve temporarily, becoming part of something larger. To be human is to seek that harmony, not perfection, but connection. Music provides a safe way to feel deeply, to explore emotion without fear. It invites vulnerability while offering unity. We can be fully ourselves, and yet held by something beyond ourselves. Even when we are alone, listening to music is an act of companionship. The brain responds as though someone were speaking gently, understandingly, just beside us. The melody becomes a friend in sound. It accompanies us through solitude, reminding us we are not truly isolated. In therapeutic settings, this companionship matters as much as chemistry. People recovering from trauma often describe music as the first thing that feels safe, a form of expression without judgment. Sound enters where words cannot go. It bypasses defenses, reaches into protected places, and offers comfort without demanding explanation. At its deepest level, music teaches empathy. When we truly listen, we practice openness to emotion, to others, to the subtle messages within silence itself. Listening becomes a form of presence, not passive reception, but active attention, a gift we give both to the music and to ourselves. Through that presence, The mind grows quiet, but awareness expands. We become, for a time, instruments of attention, resonating with what is rather than what we expect. In spiritual traditions, this state is often described as harmony with the universe. In neuroscience, it is described as coherence, the alignment of neural patterns across the brain. Whatever the language, the experience feels the same. Unity, a sense of rightness, of being in step with something fundamental and true. In that unity lies healing, insight, and peace. Music guides us there by reminding us of our own inner rhythm, the pulse that continues even in silence. When the last note fades, what remains is awareness, a quiet echo of understanding that we too are made of vibration. Our thoughts, our hearts, our breath, all move in rhythm with the same laws that shape sound. To listen deeply is therefore to remember who we are. We are listeners and creators, both instruments and composers in the great orchestra of existence. Every heartbeat is a drum, every breath a phrase rising and falling in its own time. Every feeling a melody waiting to be heard, and every silence the space where that melody finds its meaning. The science of music may continue to evolve, but its truth remains timeless. Sound is how life speaks, how consciousness recognizes itself across distance and time. As this journey comes to a close, imagine the quiet vibration that fills the space around you. The hum of air, the faint rhythm of your own pulse. That, too, is music, the background song of being alive. And somewhere, deep within the brain, a network of cells listens, synchronizes, and understands. It does not need words to know what this means. It only needs sound. Music, like life itself, begins in vibration and ends in silence. But between those 2 points, it tells the story of what it means to feel. It captures the essence of being human, the longing, the joy, the sorrow, the connection. In every note, we hear ourselves. In every pause, we find peace. And in every song, we remember that we are not alone. We are part of a pattern that has echoed since the first heartbeat and will continue long after the last.